Hi everyone. In the given problem statement of minimum window substring, we are going to given two strings s and t of length m and n respectively. Return the minimum window substring of h such that each character in t including the duplicate is included in window. If there are no such substring, you can return an empty string. Now let us look into it. For this, right, we can have two dictionary. So first thing that you're going to count the total number of individual characters that are there along with their frequency. So we can have the value of dictex and it is going to have A is there one time, B is there one time, and C is there one time. We can also have a temporary dictionary. Initially, it is going to have A as 0, B will be 0, and C will be 0. And to meet the condition, right, all the three should be same. So currently it has three different characters. So has is 3, and we can have another variable called need to be 0 currently. Now let us loop it through S. So we can type in S. S values are A, D, O, B, E, C, O, D, E, B, A, N, C. So initially we are going to get A. So once we get A right, we can add our from 0 to we can increase it frequency to 1. So now right, one condition got met. So our need would be changing to 1. Then we are going to go to D. So once we can add D to our resultant string, but D does not occur in the dictionary, so nothing is going to get changed. Similarly, O is going to be added. O is also not in dictionary, nothing going to change. Then B is going to get added. B is in the dictionary, so we can increase the B by 1 and our need is going to get increased to 2. Then we can add E and then we can add our value of C. Once we add the value of C, our C counter also is going to get increased to 1 and our need is becoming 3. At this point, we can take what is the total length, right? So our total length would be 6 right now. So our resultant string can have the value of A, D, O, B, E, C. And this is the smallest right now that we can have. Once we have add that right, we can add a while loop till until this condition is meeting, right, our need is 3. So we can remove some characters until this condition is not met. So let us remove A. So once we remove A, right, so from counter 1 it is going to get decreased to 0 and our need, right, is again becoming 2 for the time being. Then what we can do is that we can add O. O is not in dictionary. Similarly, we can add D, E, we can add B, and the B value, right, is going to get increased from 1 to 2, but the need would not change because B condition was already satisfied, so we cannot change that. Then we can add A out here. Once we have added, right, suddenly we can increment our counter to 1 and need would become 3. Now our condition has met. But if I look into the length of it, right, the length is pretty higher than the already present length. So we will not be changing it up. Now again from the while loop, we can keep on decrementing the values. We can remove B. So once we remove B, right, the counter value of B would be changed to 1. then we can remove E, we can remove C. Once we remove C, right, the C value is going to get to 0, and our need, right, from 3, it will again become 2. Okay. Now ODEBA is there. Now we can add N, but once we have added N, right, nothing is required because our conditions are not yet getting satisfied, and we can again add C. Once we again added C, right, our C value from 0, it is going to change to 1, and our need is becoming 3. Now here the total length, right, would be 7 characters, but 7 is greater than our current value, so no need to change the result. So we can remove these characters. Okay, so we have removed O, D, E, B, E, and then B, A, N, C. But while we are removing it, right, the B, A, N, C character that is there, right, here, all the values that is present here, right, it is still satisfying the condition, because here our need is 3. All the dictionary, right, temporary variables are greater than or equal to the available the t values, so all the conditions are meeting, and this value, right, is B, A, N, C. Length of it is smaller than the length of A, D, O, B, E, C. So our return would be B, A, N, C. So we can easily solve this problem using two pointers method. Only thing is that we have to keep a track of dictionary and the condition, right, all these values in the dictionary are meeting that condition, so that we have to keep a track of. Now let us jump to the Python solution. Here let us initialize two dictionaries. So first is the dictionary of dictex, and then we are going to have our temporary dictionary, which is temp dictex. Now you're going to loop into all the elements of each in t if each not in dictex dot keys. In that case, we are going to add that value to dictex equal to 1, but you also want to add that value or initialize that value to our temporary dictionary now, but the temporary dictionary would have a value of 0, because now we are not looping through s, we are just keeping a track of the values that are present, and that end we need to look for. Now we're going to add the else statement, and here dictex dot each would be incrementing by +1 because the initialization has already been done. Now we are adding two more variables, have and need. So have and need are basically the conditions that needs to be met. So 0 comma length of dictex dot values. Once that is done, we are adding few more value called min length to keep a track of length, and our pointers, which are going to be math dot infinity. So biggest length, right, could be infinity for now. And here let me import math, and we're going to have a resultant string. So res string, which is going to be empty for now, a resultant value, and a flag, which is going to be false initially. Now we're going to loop through our I bag of words in range 0 to length of s if our condition is not meeting. So if have is not equal to need, in that case the res string is going to be added s of I, and if s of I is present in our dictionary, temp dictex, in that case temporary dictionary of s of I, we're going to increment that value to plus equal to 1. Now to track, right, whether our halves are increasing, basically for that value, in if both of the values for, like say for character a, right, is same in temporary dictionary or greater than they present in the dictionary, right, then we are going to increase our have. So now if temp dictex s of I equal to dictex of s of I, in that case we are increasing the have by plus equal to 1. Once that is done, right, we are going to have a while loop which is going to remove the unnecessary characters that we don't require. So if have equal to need and j less than equal to I, if s of j in temporary dictionary, then once you're removing that value, right, so it should also be removed from the dictionary. So dictex of s of j minus equal to 1. And now again we need to check, right, if our values in the dictionary got reduced, right, then similarly you have to also keep a track, right, whether the haves have decreased or not, or the needs have decreased or not. So if temp of dictex of s of j is lesser than dictex of s of j, then our have will get decremented by 1, and now resultant string is going to be comprised of all the values except for the first character. So we can do it with the help of slicing, and we are going to increment j plus 1 and flag to be true, indicating that a character has been removed. Now if flag is true, then temporary variable, right, we are going to store all the values of j minus 1 plus resultant string. Reason we are doing it is simply, let's say we are going to remove all the values, right, for example in this case, so we are going to remove a, so we need to add that last removed value from there. So if min length is greater than the current length of temporary variable, and s of j minus 1 in temporary dictionary and temporary dictionary S of j minus 1 plus 1 equal to dictex of S of j. Mean length is going to be length of temp, and res value is going to be the temporary variable. And once this flag ends, right, we are going to turn off the flag saying the flag is false, and we are going to exit this and we are going to return the resultant value. Let me run this up. I hope there is no spelling mistakes. And as you could see, all the test cases run properly. Let me go back and try to submit the code. Now, once I've submitted the code, right, the application run properly. This is the entire code that you can look into. It's pretty simple, only 50 lines of code. So it's pretty efficient. And if I look into the time complexity, right, it would be of big O of n plus m, suggesting the other parameters, right, just to keep a track of those values. So you need to have one more dictionary. So it is going to consume some amount of space and memory to have that. But anyway, it's pretty efficient. And now let us jump to the next question.